Hello, good morning, good evening, to the audience in Taiwan and also in US. Thank you for joining us, the Data Analytics Colloquium, December 4th. This is the finale. That we saved the best to the last, and now we have a great talk today. And so let me introduce Dr. Peter Pan, who is the co-host of the colloquium. Dr. Pan, are you online?
Yes, I'm here. Can you hear me?
Oh, I can hear you, and I can hear you. Let's see. Oh, good to have you. Now let me spotlight you and then spotlight Dr. Patrick Brandt, and I will introduce our speaker in a little bit. And yeah, go ahead, Peter. Hope your voice feel better.
Yeah, well, sorry for the coarse, hoarse voices. I'm having a cold here. Morning, Patrick. All right. So good morning, Texas, and good morning, Taiwan. Welcome, everyone. So I'll just give you a brief introduction to DAC. So for those of you that are not the first time here, so DAC, DAC, that's a Data Analytics Colloquium. Today's webinar is part of the DAC, a collaboration between National Zhongxin University's College of Law and Politics and then UT Data's the School of Economic, Political, and Policy Science since 2019. So this is the sixth year. And we have been honored to bring together regarded international scholars and data scientists to share their research methods, models, or recent publication in this open and accessible format. So you're all welcome to visit our website or review previous webinars on YouTube. So today we're privileged to have Professor Brandt here. So yeah, I will let Dr. Holt to introduce him to you all. Carl.
Hey, thank you, Dr. Pan. And yeah, I'm really, very privileged and also very excited. I invited Dr. Patrick Brandt to come to this talk, and I want to talk a little bit more about Dr. Brandt. And Dr. Brandt is a professor of at UT Dallas and School of Economic Political Policy Sciences, and he is one of the first pioneers in introducing LLM and AI methods in political studies, particularly the conflict database, conflict studies, and he is also well renowned for his time series work and Bayesian works. And currently, he's providing courses, providing training, the top-notch training in these two areas in UTD. And he used a lot of methods, and but his most well-known methods, of course, is Bayesian and also time series using vector autoregression and also Poisson models. Now, his latest work and accepted for political analysis for publication is actually the latest methods introducing extractive methods and language model methods. And and as of today, and he told me that the paper has been scheduled to be printed on ink and printed on paper, and of the journal, it should be either later this month or early 2026. So in very soon, I will also post a link of the paper in the chat box. And without further ado, and let me introduce Professor Patrick Brandt.
Thank you, Carl and
Thank you.
Peter. It's
Yep.
my second time doing this with you guys, so I appreciate the opportunity to come back and do this again. So this actually is related to my time series and my forecasting stuff, Carl, because I got into doing this because I needed to basically provide and manage my own data stream and my own data set. And so it got into, I wanted to do predictions and conflict analysis stuff, and I needed to be able to extract information from news reports. So what does that look like? Very often it looks something like this. So let me share screen, right?
Sure.
You all done this. You have a browser window, you've pulled up some set of things, there are a set of news reports, something else. So here's Google News as of, I refreshed this page right before we got on here. So none of this is in my large language model. None of this is in anything else. These are the kinds of news reports, right? Navy finding substandard practices, BBC reports on the Skripal poisonings. These are all international news events. So I know if I search through this page, right, there's probably, oop, did I lose you all? No, I didn't. Sorry. Press the wrong thing here. Let me go back to this.
You're good. You're good.
Good. So I know that somewhere in this page, there's probably a story about Israel, right? So here's an Al Jazeera story on Israeli attacks against Palestinian civilians in Gaza and Lebanon, right? It's from 6 hours ago. Now, I may want, for a conflict forecasting, conflict analysis, I want to code this in real time. Or I have a lot of these I want to code. Maybe I've downloaded thousands upon thousands of these news reports. So I have one that looks like this, right? You can tell I haven't been here before. It's asking me all the cookie questions and all the rest. So I haven't staged this for you guys or anything else, right? So I have reports that look like these that are in some way, you know, talking about whatever latest attacks there have been, right? So I could have this story. I can go back a page and have another one. I could have a Guardian story. I have a Times of Israel story. I could have this one from Reuters. Again, whole bunch of them. You can tell I haven't staged these. This isn't one of these demos where I worked the whole thing out ahead of time. Here's another one from the BBC. Let me grab this one because the BBC is not going to give me a bunch of grief about other stuff. So here's the kind of news report I'd want to code. I just highlighted the first 4 paragraphs. So let me show you what we're proposing to do and what I'm going to walk you through. We have this model we've built called ConfliBERT, and I can take that text of that news report. Now here I'm just going to take those 4 paragraphs, and then I can ask it, is this about, say, politics? So it's a basic text classification question. Because remember, I may have tens of thousands of news reports, some of which have been filtered, some of which haven't. So yes, it comes back and tells me this is about politics. What I'm clicking on and having this do is access a large language model that's living on a server on Hugging Face, right? So this is our LLM living in the cloud doing this. But then I can do other things with it, right? There's my same report again. And I could go back and say, I'd like to know, is this about a bombing, a kidnapping, like some grouping or ontology or coding classification I might have, right? Where I put labels on it. So we can do that. I can ask it again for that. What is it? And it tells me here at the bottom, it's most likely some sort of bombing or explosion or another kind of event. So you might want to define out what are possible events. Is it a bombing? Is it a missile attack? Is it a drone attack? You can think about other kinds of text data where you might think about, you know, differing degrees of arms sale or differing degrees of militarized disputes. We can have it do other things then, right? So we could say, I want to find all the named entities. What are all the places? Who are all the people? What are all the groups? Right, so these are really common coding things and information extraction things we want to do as social scientists. So then when I ask that, I get another highlighted set of boxes, right? And you see it's now color-coded the whole thing. So if I color-coded it, I must be able to pull those labels out. The red labels are people, the blue are organizations, the purplish cyan color are temporal ones, and the green ones are places. There's a little dispute in some of those. You could quibble about, but you could make it better. The point is, I have very quickly coded this article, and I haven't read it. Like I copied and pasted and put it in there. So let me give you where this is coming in and what this is doing for us more generally. So this is part of work we've done around building a model called ConfliBERT. And we first did this before any of you knew what ChatGPT was or any of those sorts of tools. And we did it, we published it in an engineering computer science journal with my colleague Yibo Hu and several of these other people who are on here and have joined me. And there's been a fair amount in this. You'll see there, we've had support from the National Science Foundation. We've used the resources of the NCSA at the University of Illinois. There's a lot of grant acknowledgments there. NSF's not responsible for this. UT System's not responsible for it. University of Arizona, the rest that's there in the disclaimer. But one of the things that comes up for us is, wait a minute, we've got to decide what it is we want to do when we're going to use these large language models, or when we're going to use AI to help us do coding or help us do a data analytic task. And so the ones we care about here is, well, I want to code or extract this information from the news reports. We had come up with a model, ConfliBERT, and we started working with this back in 2021, 2022. And we did this, and then all of a sudden, this thing called ChatGPT showed up. And then Mistral showed up, and then Llama showed up, and then Qwen showed up. And everyone's like, well, why would I use your ConfliBERT thing? Because that's like 2021, 2022 technology. And so what I want to do is, let's go back and think about, what do we want large language models to actually do for us as social scientists or as data analysts or something else? And I'm going to kind of make a claim here that most of the time, we just want it to pull information out of text. We just want it to pull information out of images. I don't need it to generate anything. I have enough other noisy data and other things out there. So we got to think a little bit about what LLMs do and what they don't do. So I'm going to give you that background, and then let's think a little bit about what ConfliBERT is. So I'll quickly walk you through the 2022 paper. It's short. It's a typical engineering computer science paper. It's 8 pages long, 12 pages long. It's short by political science standards. Then I want to get you into this paper that's forthcoming at Political Analysis, which is, well, what do we want the LLM or what do we want the AI to do? And I'm going to make the claim here, we actually, most of the time as social science analysts, we just want it to extract information. We don't want it to synthesize anything. We don't want to put bananas on our images. Those are all generative things. And so what we really want most of the time is some sort of classification or extraction. And so I want to look at and talk about how we do that and how well we do that and why we want a tool like ConfliBERT and not ChatGPT and not Claude and not the cool cutting edge thing that you think you need tokens and a bunch of resources to get to. All right, so let's think about what we want to do here. We want to probably do one of 3 main things. So this is where I give my co-author and Yibo Hu a lot of credit. He came back and said, look, what you political scientists are trying to do or what you social scientists are trying to do matches up to things we do in computer science. And it matches up in a particular way, right? Most of the time we want to take a piece of text or we want to take an image or something like that and say, does this have something in it about politics? Is this about a political event? Yes or no? Is it about a terrorist attack? Yes or no? Does this news report say something about politics or does it say something about sport? We just want to do that. That's basic binary classification, right? And so in a binary classification, we're doing something like this. This doesn't want to do this for me right now. Let me do it this way, right? We have, say, a sentence, and we want to know, is this related to a particular type of violence? So that would be a typical conflict application here. And we may want to do the named entity recognition piece, which I had shown you before, right? Where I pull out what are the places, what are the people, and that part. Lastly, I may want information about particular kinds of events. And so that's the masking or coding or ontology extraction part. We'll talk about that more towards the end, but usually we want to do those first 2. I have a set of categories. I want to put the text into those categories. So we have our choice now, right? On the one hand, before about 2023, we had this class of bidirectional encoder representation of transformer models, right? These are the BERT models. And a whole slew of these got created in the last 5-6 years, right? And they're basically the next follow-on thing to doing word embeddings or vector representations of text. And what the bidirectional encoder does is it say, take my sentence and read chunks of words this way, read chunks of words that way. Or in the case of a pictogram, you know, we're reading chunks this way, reading chunks this way. You get the idea. You're going to work your way through some sequence of something, left to right, top to bottom, whichever way it needs to be done. And we got a whole slew of these that got created. They're mainly open source, easily deployable, low energy, low computation cost, or somewhat low compared to the other things, models to do extraction. They're not going to tell you a story about the news report. They're not going to tell you a story about the data you put in them. They're just going to extract out information for you. The thing that got everybody really buzzed 3 years ago was, wait a minute, now we have generative AI, right? So we got the generative LLMs. Those are the ones on the right here. And you see, we have a bunch of them. The cool new corporate thing is to be one of these providers, right? We have a set of US ones there. We have a set of Facebooky ones or Meta ones. We have a set of Googly, Alphabet ones. We have a set of mainland Chinese ones, right? And this is the new thing, right? Get me my NVIDIA chips, put them together to do this thing. And we have these big train things and we feed these prompts in and put in different text to have it summarize for that or give me an answer back. And this is all great. And most of these LLMs are really generic and nice, but they're not going to work for what we want. Because most of what we want to do in a business application, in social sciences, to study international relations, to code open-ended questions from surveys, to analyze legislation that's come through a parliament or a legislature, require a domain-specific vocabulary and knowledge and ontology that we want to apply and then extract from a particular set of documents, right? We know what the structure is and what information we want to pull out of legislative speeches or out of parliamentary debates. And so we're better off to use a model that's set up to do that. That's what an extractive BERT-like model will do. I don't need it to give me back a summary. I need to find the key things I want in it. So one of the big things that came up for us early on in this was, well, wait a minute, are we better off to just get rid of and jettison everything we've done up through 2021, 2022, or should we then continue down this path of developing these BERT models that just do extraction, or are they going to get subsumed by, and are we better off to just punt and go to these generative models? So that's the setup for where we were a year ago, 15 months ago. So we're in this thing of thinking about extractive versus generative models. And as I note here, BERT's really good at finding context. Reading chunks of words this way or this way is something it can do well, and it can find what those contexts are. It's not going to produce any summary of them. It's just going to say, these things are in there, or things like these things are in there. And so our take on this was, for most of what we want to do as social scientists, I know it's what I did for my undergraduate honors thesis. It's what I did for my dissertation. It's what most of my students I've supervised have done. They're doing extraction. So what we said was, let's focus on those and let's focus on models that extract in the domain we care about. So how did we do this or put this together? Well, when we started, we developed ConfliBERT as a large language model based on training it with particular data. We knew we're interested in studying and extracting information about political conflict, so the model has to be trained to recognize what political conflict in all of its guises look like. And so we put together a very large corpora of, at the time was very large. It was a great amount of work, but it gave us something to do when we were all trying to figure out how long we were going to be locked down during the pandemic. So if you wonder what good research came out of the pandemic, it was this. And so we built and put together data sources for training and testing this. And I can go back to the links on this, but we have them here, and we really put these together in a way to allow us to then look at this. So we gathered documents from the UN, news reports we previously had gathered on political conflict, code books and related entries, like things we know were information about conflict and conflict characteristics. We didn't go get huge grasps of everything on the web. We didn't get lots of sports stories and horoscopes and all that kind of stuff. We were very, very focused in what domain we wanted. And so we said, we're going to do this, and we're going to use that to train an existing bidirectional encoder representation transformer. So we're going to have BERT, but we're going to have BERT where it's really good at finding context and finding things about conflict. So what does that look like? Well, what that looks like then is a model that has a couple of things in it. One is it's got a lot of text in it, but it was quality text, right? We didn't just go out and say, I'm going to hoover up huge amounts of the internet. We were very focused in what we got. And we started in English. We got 34 gigabytes, which by today's standards seems very small, but it really is enough in what we have. We got specific domain corpora, different things from mainstream media that we collected under a prior grant project by scraping internet news sources like the one I was showing you for, say, Google News or the New York Times or major newspapers of record for political conflict reports. A large corpora of news from GigaWord, which is an open data consortium, linguistic data consortium source, and things we'd pulled from Wikipedia. So in the scheme of what we had, this is really small compared to, say, what trains like a ChatGPT or a Mistral or a Claude model. I'm happy to get into more of the details of this and how we got all that. But that comes together, and then we trained different models. We had to deal with, were nouns going to be uppercase, lowercase, were we going to keep proper nouns, what context lengths were we going to use? So we have different flavors of this that we tried out. But why does it matter? It matters that we're domain specific for things like this. So on the left here, you have a set of words, and you have the way BERT would split those words up into tokens. And you see BERT splits words up in weird tokenizations. So by default, it does this because it's trying to find what are overlapping sub-patterns of words that carry across context. So it splits words up by syllables in English, or it splits words up by parts and components of things that in computational linguistics we know make up the words. But it also means then it confuses words or associates words in ways that aren't sensible to the political analyst. So our way around this is, well, in ConfliBERT, we labeled and told it for some subset of these things, don't do that, right? Certain things are proper nouns that always have to be kept together. So these are examples of that. We're like, hey, BERT, don't split this up and tokenize it into, 2 or 3 different words. These are single words all the way through. So that's an important thing. It learns to recognize proper nouns that describe political entities. So we had a whole bunch of steps in this, right? One was gathering corpus, downloading it, curating it, organizing it. We then had to clean that, set it up, put that into a base BERT model, which by today's standards is tiny, right? We used a 110 million parameter model, whereas the large models now have tens of billions of parameters, right? So this is a very, very small large language model compared to what's out there. So I'm going to give you what is like a David versus Goliath or the little guy versus the big guy thing. And you're going to find that we actually still hold up pretty well. We had access early on, thankfully, to some GPUs back before everyone was fighting to get access to resources from NVIDIA. We trained this, and then we produced 2 models. One is a model trained from scratch on cased versus uncased data, so get rid of the proper nouns versus leave them in. And then we did a continuous updating model. That's more of a technical thing for the computer science guys. Okay, so we did that. We got a model. We published it. We said, look, ConfliBERT does better than BERT. ConfliBERT does better than other things you might try to do of what we knew to try in 2021, 2022. And then everybody came along and they said, yeah, okay, yeah, BERT models are not cool anymore. Everyone's going to use ChatGPT, or we're going to use Llama, or we're going to use Mistral, or we're going to use Qwen, or whatever the next thing is that comes along. And so that was creating a problem for us, right? We have this nice paper, we have this nice set of results, the model works well. I have the graphical user interface. You can go to our GitHub site and download it. I'm like, guys, we have this great model, but does this hold up? Or have we just been swept under the rug by NVIDIA and OpenAI and all the rest of the players showing up and giving us the next flavor of ChatGPT? So that kind of creates a problem. And so we started about 1.5 years ago looking at this problem. And we centered it around this question of, do the most recent generative AI models compare well to the extractive models? Right? If what I care about is extraction, does having this bigger model that can generate these great summaries and says please to me and thank you to me and allows me to give it repeated interactions and repeated queries and the rest, do as good a job as me just deploying my BERT-based ConfliBERT model to do the task I want to do? So that's where we started with this. So here's the task and the way we set it up. We said, look, we want to encode, in our case, something. Here, the example we're going to work with are terrorist attacks. Reason this is relevant is the Global Terrorism Dataset has not been updated for over 3 years now. This is a commonly used data set for those who study international relations and transnational terrorism. And the US government and the Department of Homeland Security basically stopped the grants pre-Doge, pre-Trump, all that. They had stopped the grants that allowed that database to continue being updated and publicly available to academics. So this becomes a thing we want to do. But it fits a bigger problem, right? You have digital text, right? You know a little bit about it. You've curated it. You've cleaned it. You've done the source selection, right? So this isn't, is the media biased, unbiased? This is, I have a set of speeches. I have a set of news reports. I know they come from a reputable source. I've dealt with the source bias problems I have. Now I just need to get the information out, and I got more information to get out than I have time or research assistants or dollars or pesos or euros to spend to do it. So I need to get that information out, and I need to do it iteratively, and I need to retrain or possibly update when I go to do this. So that's the basic task we're facing. And we want to know, can we do a better job of that using, say, a BERT model compared to what I might have gotten if I just stick it in the latest, or what was the latest a year ago, generative AI model? So how do we go about this, or how do we think about it? Well, we go back and we say, look, I want to try this out, and I'm going to try it out on the Global Terrorism Dataset. Now, we do some other examples and things in the paper, and I'm happy to talk about those and what we get out of those. But what's nice here is GTD, like a lot of other data sets, basically is giving you the training data, right? Because we know from the prior data sets what humans coded into the event. And we know what text they did it from. Right, so we can go back to the University of Maryland START Center. We can download the GTD data set. We can download the texts that are the summaries of all the events that are recorded there. So we have lots of data sets and sources like this, where it's really easy for us to go and say, here's a set of corpora, here's a set of labels. Or you yourself may say, fine, I'll label 1,000 documents, or I'll label 1,000 pieces of text. And I'm going to use that as the training data that I'm then going to use to augment what ConfliBERT's going to do, or related BERT model to do this. It's happening in the sciences. It's happening in legal studies. It's happening in all these other places. So we want to do that here. And what's nice is we have good examples of it. We already know that the texts that are there are events. We just want to know what kind of events they are, right? So this would be, if you're thinking in a text is data world, you had 10,000 news reports you downloaded. You filtered down and got 1,000 of them were relevant. And of those 1,000, you then need to code the next feature or detail of what's in those, who the perpetrators of the events were. Was it a bombing? Was it a terrorist attack of a kidnap and ransom, right? What was that? So those become things where, in this context, we can do named entity recognition or multi-label classification, right? So I'm going to abstract away from the binary classification part here, because there's lots of people who do that and lots of ways to do that. And then it becomes, well, wait a minute, we have to compare. And so this is going to look a little dated when you look at it, but realize this was us doing this 14 months ago, 15 months ago when we came up with this. So we looked around, we said, what do we have access to? What are the latest available large language models that we can run and deploy on our own without having to pay for a bunch of tokens, without having to pay a bunch of fees to OpenAI and the rest? And recognize I don't have to pay for compute because I have a research grant that's allowing me to leverage GPUs that I have access to. So this is the acknowledgement at the beginning of thank you to the National Center for Supercomputing in the US. Thank you for access to the Delta cluster, et cetera, because we can run these models on there. So we were able to set up and run ConfliBERT, Meta's Llama model, Google's Gemma 2 model. We're up to like Gemma 3, 3.5 now, if I looked this morning. The Qwen 2.5 model had just come out. And then my research assistant and co-author, Sharice Mayer, fine-tuned a Llama model. So we did basically what we did to create ConfliBERT, and we used trained or labeled conflict data to augment the Llama model. Right? So you think about it, we now have two kind of expert annotated or expert fine-tuned LLMs out there. We have ConfliBERT, and we have this model called Conflama, which kind of comes out of the side of this. The idea then is, let's take the GTD data as they were given to us. Let's use a portion of them to train and then another set to evaluate. So we're just going to do a cross-validation in this and ask, well, how's the human-coded data set compared to what I get from the LLM? Right? So I've left out, so the LLM doesn't see some of the stuff. We have part of it that's used to train ConfliBERT, part of it's put into Llama, part of it's put into Gemma, part of it's put into Qwen, and then we say, we want you to predict the part we didn't show you. And we know what the answer is because you have the human-coded data set that came from the Global Terrorism data set. So this gets us to then do a real comparison or a real like experiment to see how do these models hold up. So let's see a little more of the detail of what that looks like when we set it up. What that means is we've got to train those generative LLM models. Right? I already have ConfliBERT's done, Conflama's done, but I have to tell Gemma, I have to tell Llama and the rest how to do this. So I have to give them example classification prompts. So these are detailed in the appendix of the paper. And then what we did was once we gave it those prompts and said, look, we want you to classify these terrorist attack reports as being a kidnapping, a bombing, an abduction, etc., right? The main 7 to 9 categories of terrorist attacks that are coded in GTD. We gave it training text or examples for this, right? So we gave it all the data from 1998 to 2016. And we said, all right, fine. You predict 2017's data, 2018's data, 2019's data, up through 2020. Right? So we're then going to use that and use it to predict from each of these models. So notice, I'm going to have truth, humans, ConfliBERT, Conflama, right? So those are going to be the extractive AI models. Then I'm going to have the generative ones, right? The latest cool new kid who showed up, right? The Google model, the Meta model, the Alibaba model. The only reason, for those who are wondering, the only reason we didn't do ChatGPT, we didn't have the budget. And you can't run it for free, or you can't run it without paying OpenAI. And so I wasn't going to pay for the compute and pay OpenAI just for that one comparison. Okay. So how are we going to do this? Well, we have these 6 models. So this gives you a little more detail of what this was. So this was our, working with the latest state-of-the-art stuff that we had. So we have our incumbent, right, ConfliBERT, the model that Therese Mayer and I developed, which was ConfLama, right? So we basically said, grab Meta's model. And the reason we liked trying Meta's was it's open and it has open weights, right? So it's not hidden from us. It's not doing things in the background. We can't see what's getting updated and the rest. And it's relatively lightweight to work with, as opposed to, say, working with Google's model, Meta's bigger models, or the Qwen model. The Qwen model was kind of the biggest one you would have had access to in late 2024, right? By the standard of today, the latest models have gotten even bigger. So what do we want to do? Well, we want to ask, okay, great. How accurate is this? Right? So we want to know, and you can think of this as every row of data is a text for a possible terrorist attack, what the humans coded it as, what each one of these models on the prior thing coded it as, right? So I have the truth from the humans coding those events from 2017 to 2020. I have one column of data that's the prediction from ConfliBERT. I have a set of columns that are predictions of data from the ConfLama. Same for Gemma, same for Llama, same for Qwen. So then I want to make comparisons of each one of those columns for the model to what the human had coded those data to be for each one of the events in 2017 through 2020. So that'll give me an accuracy measure. I can get a receiver operator characteristic curve. I can get a ROC curve. I can get precision metrics to look at and compare false positives in the conflict identification. I can get recall measures. That is, how good a job am I of actually recovering the appropriate or the correct category of interest. And then I can look at precision recall trade-offs. Precision and recall depend on what the cut point was of where you were going to say you had a right versus wrong answer, right? If you think of binary classification, the most common cut point is to say, I'm going to split it 50%. I'm going to split it a probability of 0.5. But it's sensitive to the choice of the cut point, and the F1 score balances out what that is over a range of cut points. So that's important to us here, especially when we don't necessarily want to cut true versus false at 50% or 0.5 probability. We may want to do it at more extreme probabilities because the distribution of the thing is skewed. So we did a bunch of this to test it out at first. We did it on some simple test cases. We then pulled the data sets we had used in the paper in 2022, which included a set of news reports from the BBC, whether or not those were about political conflict, and then the RE3D data set, which is a set of events related to terrorist attacks and insurgent attacks as part of the war on terror and the U.S. response in Afghanistan and Iraq, that's used as a common benchmark data set for these kinds of problems. And we did pretty well on those. Those results are in the paper. I'm not going to focus as much on those today, but they are there, and they kind of set a base thing. In the replication materials and the other stuff we've done that go with this paper and go with this project, we've given those data sets and the full thing. So if you're trying to get started with this or see what we did, those are kind of the small toy data sets that'll let you see what's going on and how we kind of got into and did this. So how did we do? Well, we actually, shockingly, I was like, this isn't going to work. We're just going to get blown out of the water, and I had to pivot and do something else. It turns out we actually do really well. Compared to the generative LLMs, ConfliBERT gets the best performance metrics. I'll get into the details of this and how. but it performs really, really well here. It's accurate, it's precise, it has good recall, it has good F1 metrics. So it's able, with very, very little effort, without a whole bunch of prompting, without a whole bunch of other pre-training and the rest, to give you really good results. But here's the thing I think is most instructive for what most of us want to do. It's faster. It's a lot faster. Meaning, if you want to change what your ontology is, you want to change what you're coding or what the examples are and have it give you better answers, you're going to get faster updated binary classifications and faster, better labeled named entity recognitions by using a model like ConfliBERT to do your extractions than trying to ask a model that does generative stuff, the Chat GPTs, the Llama meta model, the other ones out there. And that's really important because speed's going to matter, because most of the time when we start these things out as social scientists, or we think about deploying one of these in some application, we want to iterate. We want to do something, we want to try it, we want to see how the coding comes out, we do it again. We do the same with undergraduates, right? If you train a group of undergraduates or you train a group of your peers to code stuff from text or news reports, you do a version of it, you show them the coding rules, you ask them to do it, you sit down and compare the results, you go, wow, you know, we didn't all agree on these, and so you then tweak the coding rule, and then you have to reapply them all again. And you have to restart your coding over again to reflect the revision you made in the coding rule and the coding process. And so suddenly you're looping back over those, and you have to go back and recode the ones you started with. Here, it's going to be much, much faster in a ConfliBERT model to engage in that iterative process than what you're going to get from a generative AI model. So the fact that it's more accurate and it's faster works to the advantage of us social scientists. And so my big takeaway here is that you're coming out in a situation where your domain-specific training, that is, having a model that's set up to do extraction on, say, political conflict reports, or there's other models out there that do this in material sciences. There's a legal BERT. There's different ones that have been built for different domains. Those ones are going to do better than trying to figure out how to prompt and how to get the really big generative AI, you know, latest cutting edge thing to do this. So it's this last point here I think is really important. You're better off, and you're supporting the idea that fine-tuning a domain adapted model over a generalist one. That's the one thing I've told people, really think about taking away here. Okay, so let me walk you through what the results look like in a little more detail. So here I've produced for you the receiver operator characteristics for each of the models. So if you start up here in the upper left, right, these are the results for ConfliBERT. So each of the colored lines is one of the types of terrorist attacks that are coded in GTD, right? So there's armed assaults, assassinations, bombings, attacks on facilities, on and on and on, different kinds of assaults, kidnappings. And so a good receiver operator characteristic here is in the far northwestern corner of the plot, right? Because it means you have low false positives for high true positives, right? Anything that's near the 45-degree line is like flipping coins. So we've able to separate this out for ConfliBERT, and the colored lines are for each one of the kinds of attacks. So they're way up in that far northwest corner, much more so than what you get for anything in the other five, right? The only ones that get close are the ConfliBERT ones in the very top row. So notice we have the models that are mainly focused on doing extraction or are relatively easy to set up and do and focus on the extractive task are in the first row. The ones in the bottom row, right, Gemma, Llama, and Qwen, do much worse. And they do much worse on differing kinds of events, right? Among these, armed assaults and kidnappings and bombings are the most common types of terrorist attacks. So you really want the model. It's going to get a lot of training in those, and it should do a good job in those. And it does in the ConfliBERT model, and it does for the Conforma models. You see the yellow, gold, and green lines are always up near the top. Yet it's very hard to differentiate those in the other ones. So you're just not doing as good a job when it comes to looking at or finding those. So this is one thing, and this is measuring accuracy. And you go, yeah, but a lot of times maybe I don't care about accuracy, right? For some coding problems or some things where we do information extraction, it's more about precision and recall, right? It's about differentiating, right, categories of events than it is getting the presence of an event at all. So we can look at that. That's precision and recall measures. And you see here, I've sorted these out by each of the models. And here, I've sorted them by speed. So the largest model we used here is the Qwen model. That's the one with billions of parameters. And so notice, having that model do and code all the GTD corpora from 2017 to 2020. So if I remember, it's about 30-some thousand pieces of text that we want it to code. Doing that on the supercomputer takes 6 hours. You're like, well, that's way better than having a student do it. Yes, it's better than a student, but it's still 6 hours, which means if you want to revise it, you want to do it again, it's another 6 hours. And the contrast is you could revise that, you could do that again, because the ConfliBERT version, which is more accurate, more precise, has better recall than the Qwen model, the Llama model, the Gemma 2 model, runs in seconds and processes those same documents much more quickly. So there's a set of things here we're pointing out to you. There's these trade-offs in terms of accuracy, precision, recall, and those metrics, right? Because you could say, well, you know, I'm doing just as well, and maybe there's some other thing that's done a little better by some aspect of one of the other models or something else. Great, but it just takes more time. So if you want to code more data or you want to add more features to be extracted, because once we get into this, usually once we've trained it, we've said, I want the model to find one set of things, I want it to extract something else too. I want to extract some other feature, some other information about the geography, some other information about the victim, some other thing about the speeches. In that case, you're ahead to just keep adding on to the extractive model than burdening down the prompt on the generative model. So it's performative and it's fast. And I think that's a key thing to take from here. So let me give you kind of where we are with this here, and then I'm going to say a few things then about what we've done next, because we pretty much drafted this paper a year ago. I sent this paper to Political Analysis last December, and it's just about to come out. So as you can imagine, we've done a lot of stuff since this. And kind of as a preface to the questions and things you're going to have, I want to point out some other things that have come out of this. Of the paper and the stuff I've presented to you so far, so, you know, of what I've kind of done and talked about for just short of an hour, right? It's fast, right? The thing I've noticed when I see people trying to use, say, Claude, ChatGPT, any of the rest of these, it's not fast, right? Asking it to do these tasks, giving it a large number of text takes a lot of time. And so you're spending a lot of time waiting around for it to ingest the prompt and then go through and do the thing and set the stuff up. And so speed is working against you, especially if it's not that accurate. And then you're having to go back and refine the prompt or iterate over it again, which we typically want to do. The other is what we have is extensible. I saw a few people pop up on here that are part of my research group and the rest, and I sent out an email to some of you tonight. I saw a thing earlier today where somebody has basically built an engine where you can take any sort of LLM that's already out there on Hugging Face and deploy it as an agent within another context and add whatever fine tuning you'd want. So for example, if I wanted to build a pipeline to say, take news reports that were coming in multiple languages in South Asia, translate them into English, and then fine tune and detect a set of, say, naval attack strategies that may be being used in the South China Sea with specific references to the different geographies that are used to describe the islands in the region, I could do that and fine tune that model with minimal need for the coding, basically building a set of agentic things on top of something like a model like this, which is already in Hugging Face. That's kind of a stretch, but it's not inconceivable to lay out a plan to do that today. That's not something we were thinking of when we did this 3 years ago. And the other one is what we're able to do with this is moving so fast, right? In a sense, we built a model on what was a cutting edge piece of technology that was first developed in 2017. So as I like to remind people, BERT as a model is like dealing with a child in elementary school, right? It's 8 years old. It's like dealing with a student in, their third year of primary school. ChatGPT is like a toddler. We're still trying to figure out and make sense out of what it babbles out and what it generates and how to get it to generate something sensible. And if you've ever spent time around 2-year-olds and 3-year-olds, you kind of know a lot of what comes out of them doesn't make a lot of sense. And so I think that's a thing that we should think about here. So if you're into this sort of thing, and Carl shared the paper with you, but we've tried to do something a lot of other people in this space haven't done, which is make it available, right? So this is out there on GitHub, and we've done 2 sets of tutorials now. One set that we did back in the spring, and one set we just did 2 weeks ago at the Peace Science Society meeting in Orlando. And so those are on the project site. So that's eventdata.utdallas.edu. So one thing we've done there is kind of try to keep people abreast of what we're doing, get them to that graphical interface that I was pasting the news report stories in before, and some other things. So that's the basics of the paper that we have coming out and what it kind of tells people and contributes and how to learn a lot more about what we have in this. The QR code should take you through to our website, and then that set of text boxes to put things in. That's very limited though, because we're running on the free account space of Hugging Face. If you actually want to deploy this and do more of your own text or your own local things, there's more instructions and stuff on GitHub about how to deploy this on high performance computing resources, how to get it running in a container, like a Docker container or something else on your own computer or server. We've done a bunch of other papers on this. So we had this other one where we've done and looked at what happens when we want to ask questions of the text. That one just came out in CMOT. Sharice and I have a separate paper that just came out in Research and Politics on the Conformal model. Javier Osorio has been leading a set of teams and people who've done this with multilingual stuff, where we've looked at what happens when we work with reports in Spanish and Arabic and English. And we use machine translation across those. So we take text that we already know what the translations are, and then we use machine translation to carry across those. And then we put the cross-translated stuff into versions of ConfliBERT that we've trained up both in English, and then we've trained a separate one with Spanish corpora, and we've trained a separate one with Arabic corpora. We've also done ones where we go back through and say, I want to use a code book on some other kinds of things related to political conflict and violence to train up and augment our ConfliBERT model. That's this paper on leveraging codebook knowledge that came out last year. So we've done a lot of other things. Like we've looked at what happens when we get to other languages, what happens when we get to translation. We're trying to use translation tools to kind of fill things in and get them in a pipeline to get them to this. We've looked at what happens when you try other LLMs and compare them. So we've got kind of an active space on this. I don't want you to think this is a one-off thing. We've got a fair number of things we've done around this, and we kind of owe a lot of people. We've had a lot of people participate in our group and stuff over the last several years. So I kind of give you a snapshot of them here. These are various co-authors we've had over the last decade to kind of do the work to get this to this point. I wouldn't be here sitting here talking with you if I hadn't talked with and interacted with all these people over that time. So there's a lot more people and a lot of other work that's gone into this to get us to the point of having a model like ConfliBERT and being able to do this kind of comparison on the extractive versus the generative. So Carl, I've been basically an hour here, and I'm more than happy to keep going, stop and answer questions. I haven't looked at the Q&A.
Yeah, this is exciting. And I think
so, I'll leave that there. I can certainly do more.
Sure. Let me read out Monica's question. I have saved my questions later. Monica is asking, and how is it compared to RAG?
How does it compare to RAG?
Yeah.
Okay, so that's almost in our next things. If you'd been in my research group meeting this morning, we had someone basically asking what would happen and what would go on here if I wanted to do RAG. And we've been exploring that, but the other one is it comes in with the question and answer. Most of the time, I don't need the generation part. Right? What I really want most of the time is I just want to ask a question within a corpora of stuff I have. I don't want to be referencing things outside of the documents and the corpora and the stuff I already have. So we've just started to explore some of that.
I think you are introducing a groundbreaking thing. It's some kind of philosophical difference. So you, instead of building a pool of covering everything and the big data, more and more trained data, but you start from a high quality extracted language model first, then use it for generative. That is how you save time. And
but Carl, I'm not doing generative. I think that's where you may have been a little off.
What I meant was that is how you can do a better language model to start with, right? So much higher quality, and instead of covering everything and pulling everything, and then it is the philosophy. So there's a philosophical difference between generative and extractive. Yeah, and I think Monica may have a follow-up question, and she meant the type of RAG where it only references the body or literature or the text that we give to it. Yeah.
Yes. And I think that has to be the key thing, which is I think, and but I think we're probably better off to do that in the context of a RAG step that's very closely tied to the BERT model, rather than one that's tied to the decoder side of the model. Right. I think most of what we want is, how are we better taking, say, the query or the question you have and asking, give me back the answer of whether you find this thing in this body of reports. But that to me is more of a QA problem than a retrieval augmented generation, even within those various ones. But it is a way to bound the hallucination part.
All right. May I check with Peter on your time on site? Any students have or any audience in your in Taiwan have any questions?
I think these are quick questions. Maybe Patrick can answer first, real quick. I mean, the ConfliBERT. So what about the LLM stuff and the Llama stuff? So are they domain specific, or it belongs to that general purposes, AI?
You're talking about the Conflama model or the Llama?
Yeah, ConfliLama.
The Conflama model has been the Conflama model is a Llama model that's been fine-tuned with the examples from GTD.
Okay. All right.
And so what we show in that paper, and it's a short paper in Research and Politics. It just came out a couple of months ago. We've got a really just quick way just to show that we can do that for the binary classification and the multi-label classification. And then we've got another extension of that we're working on, where we're going to ask it to do the named entity recognition as well.
Okay. All right. So the question is kind of related. You have already showed that the ConfliBERT is, perform well better than the others. And then that's where I emphasize that it's it works well because it's narrowly trained and on conflict data. So also, is there any trade-off on that, or when would researchers actually need a more general model versus the a domain specific and a well-trained smaller model? So the trade-off, because I think most of our audience are from different area, for example, the policy, specific policy, or public administration. So that kind of trade-off, what's your recommendation on that?
So I keep coming back here, Peter, because I lots of people are asking me that question, Peter, right? Because I have like my public administration, public policy, colleagues who they're like, well, I study city councils and city ordinances, and how do I use LLMs to study city policies and city ordinances? Right? Because they're like, I need to extract things out of the various things all these different cities do. It's their version of an information extraction. And I've said to them, I said, well, we need to get together a corpora of city ordinances and city policies and city statutes, and we should use that to train, CityBERT. Do we need some of those? Yes. I mean, do I think the material sciences BERT model is going to do anything for us in the social sciences? Probably not. Does it help out the guys who are doing material science? Certainly. Do I think there'd be a space for like a parliamentary BERT? Sure. I've seen people are already doing that. Right? There's a group in Hungary that I just saw their stuff the other day. I'd have to pull it back up, but there's a group in Hungary that's been building basically stuff to do coding of, say, party, the old school party manifestos problem, right? How liberal or how conservative are party manifestos across, a bunch of Western democracies. And they've put together stuff that then says, okay, based on that as your training data, if you feed in the next set of political speeches or the next set of parliamentary debates, are those more or less liberal than the other ones? So you've got these domain-specific ones that are coming up, and I think what's probably going to happen is the various literatures are going to settle in on, here's a set of models we've agreed do a certain set of things well, and they become kind of part of the standard of analyzing text in those sub areas of the social science disciplines.
Okay, thanks.
Yeah.
Yeah, I have a couple of questions from my students. John asked, do you know if this could be deployed on or try on UTD's own PC? I think I know the answer.
Yes, we have done that. I'm looking to see who else is on the call. I'm looking to see.
Glenn is on the call too.
Well, no, I'm looking to see. I have research assistants who I know have been looking at some of this. Just looking to see if they're on the call or not.
Yeah, your team members.
Yeah, I don't know if they are or not, but yes, we have had people look into doing this. And then we have also been trying to set this up in a container environment. So either Docker or Singularity, so that you then can deploy it on different servers and clusters. I will say we have taken and gotten ConfliBERT. I've had it running on the Mac I'm on that I'm talking to you on right now. It doesn't run quickly, but it runs. We've deployed it on different laptops, different tower environments, you know, and we've done it with GPUs. We've done it without GPUs. So it's that flexible. I mean, that said, the architecture around it is not what you would build if you were doing it today from scratch. Because we built this and did it, you know, 3.5 years ago, 4 years ago now. You know, so by today's modern standard of building an LLM model, or building even a new BERT model, it's not how you would put it together. But we're at the point now, like we're thinking about, well, wait a minute, if you build one of these, how do you build the next iteration? Right? Because this isn't like building, oh, I built a regression program or I built a statistical estimator and I need to update it to run on the next flavor of software or the next thing. It's a whole retraining process and rebuilding process about how are you going to do this when you're working with the conflict data in the next iteration of the BERT models. Because the BERT models today are even more sophisticated and better at tokenization and better at all the back office stuff than the one we used 4 years ago. So we're in this thing now of like, we don't know what the life cycle is of updating, continuing, maintaining these LLMs, right? So like we're exploring what that looks like with our computer science co-authors. So with Sultana Osara, who's who's the author on this paper, and Latifer Khan at UTD's computer science, and some of the other students, we've been exploring what goes into this life cycle thing, and then how do you learn about what that looks like? Because there's two sets of learning here. There's like, well, what learning are you getting as you update the underlying architecture, right? You get something that works with more memory, bigger matrices, more text, bigger context. But then you also have, well, instead of me having to do as much training, can I actively learn or continuously learn what that looks like? Right. So if I think about these other papers here, I think I put that down here. Yeah, we have this paper we just did in September at the RANLP meeting, where we looked at, okay, how do we learn from prior reports and their attributes in a way to then update and continue to have the model learn or be tuned about the next kind of thing that's coming along, right? Because the issue we have as social scientists is, you know, we're constantly getting new kinds of reports with new relationships and new actors and new people. So we need to be able to learn what their roles are and where they fit. And so we need something like active learning to do that.
Glenn wants to know, and I think you addressed this, but I still want to read it out. Glenn wants to ask, can this model approach be used to estimate how different governmental policies will be received by, I think he referred to it by the populace or different populations. Yeah.
I know people who want to use these kinds of models for that. I am really skeptical of those use cases. I'm still in the world of every time I see people trying to do something like that, whether it's the silicon samples where I'm simulating survey respondents, or I'm trying to make some sort of causal connection between, say, an event and a public opinion, or a change in a public opinion and a change in a policy. We're not there. We weren't there with our own observational or our own experimental data. LLMs aren't going to make that any easier. You know, I come back to, there's too many of these things I look at, or too many projects I still see that look like me sitting there 30 years ago as an undergrad trying to code my data for my honors thesis, where I'm sitting there going through books, extracting out and encoding information about the career paths and the districts of members of the legislature. Because I'm trying to build a data set about legislative characteristics and how they're related to their electoral fortunes. And I realize how much of that we still do versions of that today. And I did a version of it 30 years ago for my honors thesis. I did a version of it for my dissertation. I did another version of it on another project, and I've supervised other students who've had to like do computer assisted versions of that still aren't up to what we have here. And you think of how many dissertations, how many research papers you read that are about, you know, some data analytic application that very often, Carl, are someone just wrangling the text or someone wrangling the tables from somebody else's database. And I'm like, oh, okay, well, you know, any tool I give us that lets us do that better is certainly making the research work better.
Peter, do you have any questions from your side?
Yeah, here I got a couple here.
Good.
Let me try to. Okay. Yeah, Patrick, did you mention that the GDP, I mean the GTD database hasn't been updated since some year ago? And then so I think this is related. It's so fast, right? It takes seconds versus minutes and hours, and so could that be used for real-time monitoring, conflict monitoring, or early warning systems like that?
So now you're verging onto my other research, which that could be a whole other presentation. You know, one of the reasons we want this kind of data and we want it quickly is I either need it so I can code a conflict severity dependent variable outcome. I need to count the number of people who are injured, maimed, killed, bombed, etc. Or I need to know where that happened, right? Or I need it as a characteristic, or I need to know of the people doing the attacking or the rest, I need to know who they are, or I need to know where they are, right? Because that becomes a predictor variable, an independent variable that goes into my predictive model. And one of the things we've gotten stuck with on the conflict prediction, forecasting, inference literature is all of our data are still resolved at the levels of countries in months or physical a real, you know, draw a polygon on a map, geographies at relatively aggregated time units. So the high level of aggregation makes it really hard to tease out different kinds of causal inferences, different things about groups, right? And so there's this really interesting idea that's come up in the conflict literature about, could I just extract more information about groups that's not just tied to their geographies? Because groups move, right? You think about the RSF and the RAF combat in Sudan. There's just massive amounts of movement those groups engage in. And so I think you could use it towards those things, but I think it's more about getting better data quality. And I think we're on the edge of this, like trying to figure out some more of that. When I had a paper 3 years ago where we looked at what happens when we take a bunch of event data and we feed it into a conflict prediction model for, say, all of Africa or a large chunk of Africa in the Middle East. And it turns out putting different characteristics of the event data in, like the GTD type data or like this, actually doesn't improve the predictive model that much. And the reason why is the data that you're trying to predict and you're working with there has been aggregated up to the month. This at least gets us some way to think of getting data that's daily, getting data that's weekly, or broken down more. And so I think in that regard, we can do a lot more, but it also means I can go in and do a lot more of those kind of RAG QA type questions that come up around that.
All right, thank you.
Oh, there's another question from Monica. And can this model approach, I think you addressed this earlier too, be used to monitor daily online conflicts? Example, social media posts to official reports by cities and law enforcement of potential delinquents to investigate them?
So I've been really hesitant to do any stuff or to try and deploy any of this stuff to do extraction on social media, because the social media reports are so colloquial that trying to train a model to understand the context in, say, tweets or Facebook posts or Instagram images or the rest, it's so hard. I've kind of stayed away from that. But I think you could use it on, say, official reports, signals intelligence, law enforcement type reports, something that's got a little structure to it already, because you do have to think about what is the text you're putting in. One of the conversations I've had to have with people as they look at this and try and work with it is like, well, what is the unit of analysis that's going into the large language model? Right? Is it, like I showed you that example, the first 3 or 4 paragraphs? It knows how to process those. If I gave it 10 paragraphs, the context gets too long, right? The BERT model can only ingest but so many tokens or so many words, right? So yeah, media posts are really short, but there's very little context to them unless you put them with all the other ones around them. And so you're in this thing of like, well, what is the thing you're asking the LLM to do or summarize or generate or extract around? And if it's just short sentences, snippets, accounts of reports that are short, like the news article I showed you, or like the GTD event summaries, then it's relatively straightforward to do. And a lot of times that's the thing we have a lot of volume of. We found, though, that, say, when we want to do this and deploy it on, say, legislative speeches, we have to spend a lot more time thinking about, well, what is the unit of analysis? Is it the whole set of speeches? Is it the speeches broken up into sentences? Is it just the opening speeches made by the legislators at the first time they speak, not all the follow-up speeches they might make or the debate they have? Right? So you've got to then really decide what's the important part that you actually want to deploy this extractive tool on. But that to me is a social science problem, not a methodological like tool problem. So Monica, I may have given you less of an answer and more of a research puzzle. But the take on this is I presented some of this at another meeting, and a lot of the people there were studying trade agreements and treaties, and they were trying to shoehorn these really large trade and treaty documents or these really big contract documents into ChatGPT. And they kept saying, well, it's not giving me really good answers. And I said, well, what are you doing? And they're like, well, I cut it into paragraphs. And I'm like, well, why would you give it whole paragraphs? Because the paragraphs are, some of them are really long, right? They're in a trade agreement. The paragraphs are really long, right? I said, so why is that your unit of analysis and not, say, the articles or the provisions or something else or the sentences? And so then there was this whole debate about what the context should be and the rest. And I said, that's a different question, because now you're changing what it is you're trying to extract and what it is you're looking across.
Mm-hmm. All right, great. It looks like you have more research projects for you to next semester. Yeah. And now, can you talk a little bit more about your next steps? And I think you mentioned about that. So this paper should be published either this month or early next year in political analysis. So you are actually doing a lot more, and give us some directions, and because now things are moving very fast, and Gemini 3 and moving in the direction of TPUs, and then OpenAI is struggling how to go through the next breakthrough. So what is your take on the future direction of all
So
this
I see my research assistant Dagmar turned her camera on, so I may give her a little plug here, because she's part of a bunch of these actually.
Yeah.
And so it's good you've gotten your face up there, Dagmar. I'm not going to make you talk unless you want to, but I think I can fill some of this in. So one is this stuff we've done in the active learning, because one of the things that comes in here is, well, how much do you have to code of the stuff to engage in the fine tuning, right? Because you do have to give the model some set of examples to which it's then going to deploy and learn from, right? Because it's very much like when you're training the research assistant to code reports or code text, you have to show them a bunch of examples, right? So we've got to determine how many examples, how many labels do you have to put on the thing? How many different cases do you have to show as examples to the RA, where here you're replacing or substituting the RA with the large language model or the BERT model. So that's the active learning step. And we've got stuff we're doing on that. That's basically, I didn't put the link in here. I thought I had it. Hold on. No, I took it out. That's the paper that we have in the RANLP meeting in September. So that's on the webpage, or the link to it should be on the webpage for the event data project. The other one we've looked at are these things on machine translation, right? So one of the things I can remember, Peter, you've been around at this long enough, you may remember back when people of our vintage were in graduate school, there was a lot of this effort of, do you have to go and study a whole area and study its culture and know its languages to be able to study the politics there? And there were these raging debates around this here in the US, related around all the stuff about area studies and rational choice studies and the rest. And so there was a whole group of people who would go and get all this advanced language training so that they could read, process, understand the documents and the cultures of all these places and things. Dagmar has been great with this. She has a background as a linguist and has been part of some of this work with Javier Osorio and some of our other co-authors, where you know, we had started out and we were working with teams doing stuff in Spanish, Arabic, English. And then we were cross-coding corpora across those three languages and trying to figure out, do we need one ConfliBERT model, or do I need a ConfliBERT in Spanish, a ConfliBERT in English, a ConfliBERT in Arabic, a ConfliBERT in Mandarin, a ConfliBERT in, you see where this would go. I would suddenly have hundreds of ConfliBERTs. And we're like, well, that's not really the right strategy, but where's the limit? And can we just do certain languages, or can we learn across the languages? Well, what's come out, and Dagmar's been part of this across a bunch of the papers, is what happens when we use the machine translation? And how does that come out? And the great thing there, let me go back here, is that's become what's now this paper, right? The Keeping It Local paper that's here on LLMs in native and machine translated stuff, right? That was from this meeting. And then
There's a second one.
yes, I didn't put the second one here, did I? I thought I did. I forgot.
It. And a third one in progress right now.
And a third one in progress, yeah. The one in progress we'll wait on, but the other one is this one, The Devil's in the Details, that we just had late this summer. So that's this one here, where we're then looking at what happens if we use machine translation to move back and forth across these languages. And here, what we've benefited from is we as political scientists and social scientists actually have nicely aligned corpora, right? We have things like the United Nations corpora, where you have lined up sets of things in English and Spanish and Arabic and other languages. And we then know we don't have to argue about what the translation is, because the expert translators have already done it. And so we can use that to evaluate what comes out. I think the key thing here is this part at the end, right? The quality assessment reveals there's a lot of translationese in the vocabulary. And then that there's general and domain specific vocabularies that come through here. And so you have to think about what the consequence of the machine translation is. Circling back then, that's kind of this extra use case piece at the end, which is the other paper that Dagmar makes reference to that they're working on, and then her own work for her dissertation, where she's looking at policing reports and national prevention mechanisms to protect human rights in detention settings and the rest, where we contemplate this sort of problem. Dagmar has about 700 some reports in, Dagmar, was that 40 languages?
Something like that, yeah.
Yeah, it's like 700 reports in 40 some languages over time. And we know what we want to extract, but you have this multilingual document organization thing, and we know what we want. We just would have to go through those, and you'd have to know all those languages and know all the characters, and then the documents are organized differently. It would be a monumental project that you'd need a huge multinational, multilingual team to do. And we're able to deploy some of these tools and the things around them to start to make some sense out of that without having to build a team and a project around this, when I've seen similar people and similar efforts done on, say, trade treaties or other rights regime agreements, where you have to build a team and spend 10 years doing this. And that's not going to be the case for what Dagmar is doing. The other one that comes out then is, we've done these models with the Spanish and Arabic and the question and answer for those. That's where we're very much working now, because what we've discovered is people want to be able to put their text in. So I think this is what Monica was really asking about, is if I have a bunch of text and I know I want to ask certain extractive things, can't I just go in and ask it a question instead of me having to get a bunch of labeled things? And I think we're nearly there. cross my fingers. I think we can get something there probably in the next few months. So, you know, you ask Carl, what are we working on? I think it's that sort of stuff. And the other is I know these things are being used. I've kind of collected a list, and I know people at the Uppsala Conflict Data Project are using versions of ConfliBERT to encode the data for differing kind of side projects to the global event data set and some of its characteristics. It's being used on a couple of projects at the Conflict Crisis Early Warning Group, at the Bundeswehr in Munich. So I mean, there's definite uptake going on with different audiences, and our co-author Vita D'Orazio has had some conversations with the people at the Peace Research Institute in Oslo. So there's definitely use cases and things coming up in this space going forward. And I think the other one is we're getting a bunch of things that are faster, and we've got enough infrastructure around this that you can kind of follow what we're doing as a model for the next one. So that kind of circles back to Peter's question of, do I need one of these for all the domains? No, but I also think if someone needs one for a particular application, the barrier to entry to doing this has dropped dramatically in the last 36 months. You know, things I wouldn't have told someone to try and do for a dissertation 2 years ago, they're doing now, right? If Dagmar had come to me with her dissertation idea 2 years ago, I would have been, no, there's no way you could do that. And we're kind of on the cusp of seeing some results and things out of that as we go across it.
Exactly, because you know, because you mentioned that maybe at the end of your sharing that the agentic thing, the pipelines, you translate, detect, and extract. So this kind of thing is, well, it didn't happen like 3 years before. So what? And then the question comes that what research questions become possible, just like you just shared, that with these automated pipelines that weren't before. So then there are more possibilities come out. And then that related to your analogy that the elementary school student versus a toddler, right? And I think that's fun, but in a way that, I don't know, so are the generative models fundamentally different? Maybe, you know, they're different tools instead of just younger. You know, if they're younger, they follow the same growth path. But if there are different tools, and maybe we will use a different, I know that you use that analogies for, you know, different perspective, but we just practically think of it. I think that's a different track or different development. Maybe, I don't know. What do you think?
That may be another way to put it, right? Is maybe it is a different, is maybe I should adjust that. And one of them is a, you know, one of them's a toddler playing cricket, and the other's an elementary school kid playing football. Okay. Right. And that may be, and they're on very different paths of where they're going to go from that. And that's probably legitimate. Where I think this is going to get interesting as I kind of advance the slide here is, you know, we've got a little bit of an answer on this first one here. But I think the other ones are still out there, which is, how are you going to build, say, dynamic sets of connections among actors? The one of these that I keep pointing out is we've got access to a set of corpora about drug violence in Latin America, and then a set of historical reports about human rights violations. And the issue that comes up there is you want to know things about the networks. You want to know where are the cartel and the drug operators acting, against whom are they perpetrating crimes or atrocities? Are they doing it in concert with or against policing and other military and state forces in the area? So you have these moving dynamic networks, and you need to then detect who are new people entering them? Who are people leaving them? How are they changing? And we're not there yet because we're still trying to figure out, okay, great, I found the named entities. Which named entities are near which other ones? And can I use that to predict the next one? Right? So that's still out there. I think we're on the edge, though, of being able to build or really automate building high quality textual data sets, whether it's like the GTD thing, trying to follow on some of these earlier ideas that came up in, say, the McManus and Neiman paper in 2019 about things about military exercises. Vito DeRazio has been working a bunch on that. The SNARP project that's led by Chris Ferris and Thorne Wright and Reed, they've been working with some of this now with Rebecca Cordell to basically say, how do we encode stuff about human rights reports and kind of take the human bias out of it? So there are those sorts of things going on. And I think it does create these new things where we've spent a lot of time becoming domain experts in how to filter text. And this just helps us do it that much faster. But we've got to get sensitive to what that means and when it works and when it fails. And we're going to all face the, okay, someone's going to come along with a peer-reviewed paper or a manuscript, and they're going to say, I took all the giant set of text and I fed it into this thing. And you've got to decide whether to trust the data that they then are analyzing. So we've got to know the answers to these sorts of things to know whether we can trust it.
All right. Let's see and then collect another round of questions. And then do we have any more questions for Dr. Brandt? And I encourage you to check out, if you check out Dr. Brandt's QR code, and also you may want to check out the website. And so that is, let me put it up here, and that is the event data utdallas.edu. So that is the website. You can get the most recent research paper and even with a GUI with a config hosted. I think it's hosted in Hugging Face, right? It's a live, and that's the one you demonstrate that you can go check it out there.
It's live at Hugging Face, so it's you're always fighting the bandwidth of what Hugging Face is willing to let you do. Our take on that is experiment with it, use it to try it out. And my guess is what's going to happen is if you really want to put it into production and do something, you're going to be working with your own local environment to do that. We do have some good examples up there, though, in the workshop stuff, and then on the GitHub page where we show you how to set it up and use it in, say, a Jupyter notebook. And that we have found is really useful for getting people started with it, because then you're not having to do all the software setup and the rest. You just can run it in the Jupyter notebook and see what that looks like for, the example data sets that are there. And we've done that tutorial now in 2 different venues. Dagmar was just there with it for the workshop that we had at the Peace Science Society meeting in Orlando 2 weeks ago. So that's gone pretty well for us, and we're happy to take more feedback or other things with that. And the great thing there is once you get that example running, if you want to flip it and put your own data in, that's not a hard thing to do.
Yeah, this is something really exemplary is that you post everything, open everything to full access, and look at the richness of your GitHub repositories and on your website, and the students and from Taiwan or from US can. I encourage you to check out this GitHub and repositories and also the website, and you can see a lot of materials, a lot of things that you can use it for your research, for dissertation, and also mimic the process that how Dr. Brandt opened up his research results and the source codes. Yeah. All right, and this is a really, really great example. All right, and do we have more questions for Dr. Brandt and Peter?
Yeah, I think that's about it. And yeah, some other. Yeah.
I want to make sure
some
the
stu-
guests
yeah,
feel
some
like they
stu-
got what they paid for.
Well, some students still, I think they're still thinking about
Peter pays for it.
choosing, choosing between the generative and the extractive models. So they're still trying to figure out,
Well,
which one to choose from.
yeah, and Peter, I mean, on that, when we put that out there, I will tell you, it's one of these subtle differences that comes up on the researcher user side that most of the public and most people who are hearing about AI, it's lost on them that it's two different things. And I think Dagmar may have heard this story, but I was in this to have I was having work done on a tooth, and they took X-rays of me, and they told me they had dental AI. So they were able to compare the images from my teeth before to the new images to basically project or predict whether they had cavities. So it's a classification problem, my teeth. And the dentist is sitting there and he says, well, this one's probably a cavity, but this one's not. So he's labeling true positives and false positives. And he's pointing this out, and then he's got a set of monitors, so I can see one monitor where he's showing me the images of my teeth, and he's looking at the other one, and I can see him moving the cursor, and he does the labeling. And I joked with him. I said, well, did you get paid for that? And he's like, what do you mean? I go, you're providing an annotation. You're providing your expertise. You should get paid for that, right? It's like you're a consultant for the dental software AI company. You should be getting paid for that, right? Just like we'd pay a research assistant to do annotations. He's doing coding. He should get paid for doing the coding. And he's like, no, it's just what you do with the software. I'm like, oh, okay. So this is a really great idea. The guys who have the dental AI have basically harvested all the dentists to do all their annotations for them. Right. So they basically have hoodwinked a bunch of experts into doing all their annotations. And then the dentist doesn't catch that kind of AI. That's extractive AI. You're extracting information about my teeth and labeling it, and then trying to use that to get a better predictive label of the next tooth.
Mm-hmm.
Right?
Mm-hmm.
It's a purely extractive AI thing. And I said, well, that's really nice. You have the AI in the practice. I said, is it helping you out? And I'm thinking, is it helping you do a better job at the extractive predictive task you have? And he goes, no, the AI is really useful. He goes, it helps give me really good summaries of the patient and the patient's treatment so that I can provide it to the insurance companies so I can write the reports faster so I get reimbursed. And I just didn't say a word to him, Peter. I just was quiet. I'm like, because the only thing he thinks the AI is the generative AI.
Yeah.
Right? And I'm like, there's another part to this, right? The extractive part is what you need to have working, because if the extractive part wasn't trustworthy, you couldn't believe what you got out of the generative side. Mm-hmm. And the generative side's actually the one that's kind of easy. It's kind of like an RStudio, R Markdown report. You're just plugging in the data in the slots in the report. Mm-hmm. Right? You're just saying patient appeared on, fill in the date. Patient opened their mouth this wide. Patient had this many teeth in their mouth. Of the teeth that were in their mouth, this many had suspected cavities. This many had, I mean, that's not even, I mean, it could be generative AI, but it's not really interesting generative AI. Mm-hmm. Right? Because there's no inference involved in it. There's no summarization involved in it. It's just slot filling in a formula. Right? Mm-hmm. It's the same thing we have students do when they write up their regression analysis results. Mm-hmm. But to him, that's the AI. And so, like, just sitting back and going, well, wait a minute, what is the task I want the AI to do? For most of us on the social sciences side, the real payoff in this is going to be get rid of the drudgery work of me getting the data organized.
Yeah, this is it is more. Some students will believe that is generative AI can build new knowledge, but in your case, extractive is really the one that builds new knowledge.
Right, because I just want more data. I want more data, and I want it faster.
More quality data, better quality.
Yeah. Because you know, it's the argument. The data is the new oil.
Yeah,
indeed,
exactly.
But you need to do more, and if this is a non-refinery, and so then it still needs some good work. So when it comes to the knowledge and how much you get innovative knowledge, and then that is the extractive AI. I call it, maybe you should call it, it's not, instead of AGI, you should call it ASI, which is artificial specialized intelligence. So yeah, you should get that patent on that. All right. Okay, this is great. This is like a feast.
Better idea how to differentiate it too. Yeah, it's very important.
Yeah.
Well, I appreciate the opportunity to present it to more people and have more people see it. And as I said, we're happy to take feedback, comments, and we're very actively working on this stuff right now. I mean, we're kind of trying to figure out what our next follow-on things are and the rest. And I'm going to be really curious when, you know, we've now presented this, probably this is maybe Dagmar, maybe the 6th or 7th audience this has gone in front of in the last year.
Yes.
So really it's, you know, you're in this relatively small group. I think this actually, now that I think of it, the number of people on here is probably the largest group I've presented it to.
Yes.
Dagmar's been around for a bunch of them, so this is probably one of the bigger ones. So
definitely.
You're getting a definite exposure here.
And hopefully you can bring to the bigger audience in person, and maybe the next project we're working on.
We're looking forward to it.
All right.
Okay.
Thank you. And Peter, do you have any additional questions or suggestions or comments? And I'm really appreciative for this great presentation, a lot of great ideas. Now, corrected a lot of. I wish all my class, all my students are here. They can get to know and maybe correct the impression about AI, impression about generative AI, and most important thing is to help them really know how to use the AI in the productive way, the knowledgeable way. Yeah. All right, Peter.
Yeah, I think that's about it. And then I think that's a great presentation. It's very informative and insightful. Yeah, and then I believe my students here, they get a better idea, you know, between the two. Otherwise, you know, they just kind of have the clear cut up between these two. I think thank you for sharing that with us. And I think this is a season finale for our DAC for this season. So I really want to appreciate, Dr. Brandt for this presentation, and thank you for coming back too. Yeah, this is our second time we have your lecture here, so I appreciate that. So Carl, you want to have some final remarks?
I think that should be it. I think we have really good, great conclusion of the season, and thank you again, Patrick. And I look forward to your next wave of innovations. And now you're very productive, and also you help a lot of students to get well placed. And I think this is a great thing, and the project is particularly productive and helping a lot of students, helping a lot of our students too, and data science or in Jinpa in Taiwan. Really appreciate it, and look forward to having you again in soon future.
Yes. Yeah.
Appreciate it so much. Thanks, guys.
Yeah. And it's quite late.
I think I will end the event, and thank you very much for supporting Data Analytics Colloquium, and all our videos will be uploaded to our YouTube channel. You can look it up, and Data Analytics Colloquium, and look up our previous videos, and any more materials will be shared in this team's channel. All right. Thank you all.
Thank you. Thank you all. Thank you very much.
We have a great semester in.
Yeah.
Bye.
Good night. Bye-bye.
Bye.
Thank you.
Good night. Good night. Good. Yeah.